In this video, I want to give an overview of the concept of integer arithmetic. At face value, it can seem pretty straightforward, and I think it is, but it's also one of the topics that I see a lot of mistakes from my students. I think just not paying attention to signs depending on what operation they're doing. So my hope is to give some little insights to hopefully make it a little bit easier to get more of these problems correct. First of all, before we get into the actual math, we want to understand what is the arithmetic and what are integers. There are a lot of times, and we've talked about this in other videos, and I've talked about this with my students, we sometimes just take for granted what we're doing, especially in a class like math where we don't actually understand the vocabulary or the terms that we're doing, and we don't take the time to understand the formulas. We just kind of do it, and I like to more fully understand something when I do it. I want to know what the terms mean. I want to know why each step is being done, what it means. So hopefully this video will give that. So first of all, what is arithmetic? It's just basically addition, subtraction, multiplication, and division, the building blocks of math. And I think just like integer arithmetic, all arithmetic is somewhat taken for granted as like just easy math, like just basic math. But if you don't really understand the basics, you'll never have hope of understanding some of the higher level patterns that come with further math. So I consider it to be, obviously one of the most foundational pieces of all math that we do, and I push it a lot with my students because it is so foundational. And again, you really have no hope of being really strong in algebra or geometry or a lot of the other fields of math if you can't see the patterns from just basic arithmetic. So then what are the integers? Integers it's just simply a class of numbers, all the whole numbers and their opposites. So 1, 2, 3, 4 up to positive infinity, and -1, -2, -3, -4 all the way to negative infinity, and 0 in the middle. And you'll notice that we don't include the fractions, right? So there's no like halves or decimals or anything like that, which can make it a lot easier, I think, to work with these in some sense because you don't have to worry about kind of the messiness of fractions and decimals. It's just whole numbers and their opposites and 0. Some context that we might see them in. Sports, for example, obviously we're used to seeing positive integers all over the place, but even negative integers in a sport like golf, right, you see negative scores. And in temperature, certainly, we'll be using that a lot today in some of our examples. We see temperatures that go above 0, temperatures that go well below 0. And also in money, right? Like if an account is in debt, then that is technically a negative amount of money. Okay, so again, we want to just think of this number line structure, positive numbers going to the right or up, negative numbers going to the left or down. I think one helpful illustrative example is to think about the numbers like charges, right? So like this is +1, this is -1. So if I have +3 plus +2, that's obviously just 5. If I switch the two numbers and have +2 plus +3, that's still just +5, obviously. And that's one of those properties that it's just obvious, right? It's intuitive, but they do give it an official name, commutative property, meaning that when you switch the order of things, you still get the same answer. Okay, so there's a little extra vocabulary for you. Now, what about when we add opposites? So what if I have +3 plus -2? Those are just going to cancel out. So every pair of a blue charge and a red charge cancels out. So that cancels out, that cancels out. I'm left with +1. Okay. If you flip them and you have -3 or 3 negatives and 2 positives, again, 2 pairs are going to cancel out, and you're left with -1. Okay. And throughout this slideshow, I'm going to have a couple slides that's just practice problems. I'm not going to go through them, but you're welcome to pause the video and try some out for yourself just to make sure you understand it. Two contexts that I see a lot in math books that I also agree I think are some of the most helpful are temperature and money. And so we're going to be using both of these contexts to help us understand this a little bit more. So first of all, temperature. If the temperature is 5 degrees out and it drops 7 degrees, how cold is it out? It would be -2, right? And if it's 25 degrees out and it drops 30 degrees, it would be -5 out. But what if the temperature is -25 and it drops another 30 degrees? If you think about it for a second, you should realize that it would be negative 55 degrees out. And then what about when we subtract a negative number? So we could see here when we were subtracting a positive number, right, we're taking positive 30 away from negative 25. That's going to stay at negative 55. But what happens when we subtract a negative? So now I want you to think about a money context. And one helpful way to think about it is like canceling a debt. And I'll show you what I mean in just a second. So suppose you have no money. Suppose you have no money and you need to borrow $5 from your friend for food, and he wants you to pay him back later. How much money do you have now? And sometimes you might be tempted to say, well, I have $5. And you might have for a moment, but remember that you're going to spend that on food. Okay? So you bought the food, and now you just have a debt of $5. Now suppose you borrow $3 from a different friend for lunch money. How much money would you have now? Well, because you're also spending that money for more food, you're consuming the food, you're not keeping the money, so you're in debt a total of $8 now, right? So I was in debt 5, I just added another debt of $3 to my debt, I'm in debt $8. Now suppose your parent gives you $20 for allowance. How much disposable income do you have? That's an important phrase, disposable. Because we have to remember that if we're being honest with ourselves, all of this $20 technically does not belong to us. We have $8 that we still owe to other people, right? So we're in debt $8, we just got a nice bump of 20, but we actually only have $12 of disposable income, right? Disposable money that we can do whatever we want with. But suppose your first friend, who you borrowed $5 from, decides to cancel your debt as a gift. How much disposable money do you have now? You cancel out that negative $5, that debt that you had, you'd subtract that, and now you're back to $17, right? So when you subtract a negative, that's the same as adding a positive. So again, subtracting the negative of a number is the same as adding the positive of that number, okay? Subtracting the negative of a number is the same as adding the positive of that number. Or more cleanly, with some algebraic variables here, a minus negative b is the same as a plus b. I'm going to make another video on this at some point, but I know some people get thrown by algebra because they say, oh, it's the alphabet, right? When did the alphabet get involved in math? But it's actually super helpful for stuff like this because instead of having this long sentence that you have to try to memorize, you can just look at this rule and it sums up the whole thing, right? That's the clean part of algebra. That's what it's really the beautiful part because it can take a lot of examples that we can practice and sum it up into one simple thing by just using letters to abstract the problem as one ultimate example. Okay, so again, a minus negative b is the same as a plus b. Another way to think about it is opposites. So what is the opposite of yes? No. What is the opposite of no? Yes. What is the opposite of yes? That would bring us back to yes, right? Because the negative yes would be negative no or just yes. And it's important here to notice the parity, right? So notice how when there's an odd number of negatives, it's ultimately the negatives will cancel out in pairs, but there'd be one negative left that would keep it a negative 5. But if I have negative 5, that brings me back to a positive 5. But if I have 5 negatives, that keeps it negative. If I have 6 negatives, makes it positive. So it just alternates back and forth. And it can get redundant. But the main point is that a negative is a positive. Those negatives will cancel out, just like we saw earlier in the video. Another way to think of it is, like we were saying, opposites, right? So we're combining these two ideas. Okay, so these are two different ways to think about it. So far we've covered some different rules here. Again, you can do infinite examples, and I'll show some more examples in a minute. But this is really the bulk of it, right? This is really the core piece here. And of course I could just make a 2-minute video and just show these, but I don't think you'd really appreciate what exactly is going on without some drawn out examples, right? Without some context. But again, once you do understand it, you can appreciate how simple it can be written with just a little bit of algebra. So a minus b is the same as negative b minus a. So if you're not comfortable subtracting a bigger number from a smaller number, you can just flip the order and put a negative on the front. So 3 minus 5 is the same as negative 5 minus 3, or just negative 2. If you add a negative number to a positive, that's the same as just subtracting that negative from the positive. So if I have 7 plus negative 6, that's the same as 7 minus 6, or just 1. If I have a number that's already negative and I subtract a positive, if you think about it, you can just add the two numbers together, right? So if I have like negative 6, take away 8 more, I just add the 6 and the 8 and just put a negative on it. That's negative 14. Or as we were just talking about, if I have a minus negative b, that's a plus b. For example, 9 minus negative 7 would be 9 plus 7, or 16. And I encourage you to pick random values for a and b. That's the beauty of algebra, again, that you can put in any values you want for a and b, and it will still be true. So these rules apply to any numbers. And here's some more examples for you to try out. So we've done addition and subtraction. How about multiplication? These are the main rules to remember. And one thing to note is that when the signs are the same, you're going to get a positive result, right? A negative negative, as we talked about, is a positive. Obviously, a positive times a positive is a positive. That's what you've been doing for most of your math life, right? Most of the things that you cover in school are positive times a positive. But then when you switch the signs, you have positive times a negative or negative times a positive, the final answer is negative. But why? So obviously this first one, right? Positive times a positive is a positive. We know that, right? 4 times 3 is just 3 4 times. It's actually how they used to write it. They didn't say in old books, they wouldn't say 4 times 3. They would ask, what is 3 4 times? And you'd say, well, that's 3 plus 3 plus 3 plus 3 plus 3. And that would get you 12, for example. The same idea would apply if I said, though, what is 3 times negative 4? That would be negative 4 3 times. So that would be negative 4, negative 4, negative 4, or negative 12. Okay? And let me zoom that in a little bit more so you can see that clearer. And then again, recall that a negative negative is a positive. So if you have two negative numbers being multiplied by each other, it's going to cancel those two negative signs out, and you're left with just the positive value. So again, we have this. And the cool thing about division is that the rules are no different, right? So notice the little jumping jacks I'm making. But the cool thing is that when you write these rules down, they're no different for multiplication and division. The same rules apply. A positive divided by a positive is a positive divided by a negative is a negative divided by a positive is a negative divided by a negative is a positive. And there's some more practice problems for you to try out for multiplication and division. And that finishes up this video. Thank you for watching, and I hope this was helpful in helping you to better understand integer arithmetic, addition, subtraction, multiplication, division. Thanks again for watching. I'll see you in the next one.